Let's start. So here, as you can see that here, like when you see this clockwise, okay, direction. So here we are assuming the direction of current, okay, and these are three loops that I have in with me, okay, and I need to find out this Ix and this Iy. Okay, so I know that to you know uh, to solve two unknown quantities, okay, I need two equations. But here you have one more current, that is this I1. Okay, so this I1 is also needed here. So that is the reason why we have these three unknown quantities, and that's why we have to write three equations. Okay, so we'll be writing KVL equation for three loops, okay, as mentioned here as 1, 2 and 3, all these three loops. Okay, we'll write KVL equation, and from those three equations we'll find out three unknown quantities, that is I1, Ix and Iy. So this is what we have to do in this problem. Okay, so what I did, I separated these three loops, okay, and then I'll write KVL equation, and then I'll try to solve those three equations and get the value of I1, Ix and Iy. Okay, so we'll start with the first loop. Okay, so let me clear this first. Okay, so when I start this part, okay, so this is my first loop. Okay, so I can name them as A, B. Okay, so if you look here, okay, so this is your, when I'm saying A, B, so here this is A, B, C, D, E, F, G, H. Okay, so here we are talking about this A, B, and G and H. Okay, okay. So after that we'll talk about B, C, G, F. Okay, anyone? Please note this, students. B, C, F, G, B, and C, D, E, F, C. Okay, and the first one is A, B, G, H, A. Please note down this. I'll ask you after some time. Okay, so this is my three loops, 1, 2, and 3. Okay, so these are the three loops on which I'll be working. Okay, so please take a snap of this. I'll ask after some time. So when I look into the first loop, let's try to figure it out, like how to solve this problem. Okay, so when I have this, so it was, can anyone tell me what are the values A, B? What about this? A, B, C, D, E, F,
GH, sir.
G, H. Okay. So G, H. Okay. So here we are applying KVL in loop A, B, G, H, A. Okay. So this is my closed loop. Okay. So now the direction of current is assumed to be clockwise here. Okay. You can see the clockwise assumption of current. Okay, so here again you have to see that if it is going from positive to negative, it will be a drop in potential, and drop in potential is always associated with a negative sign. Similarly, if it is moving from minus to plus, okay, it is going from negative to positive, so it will be a rise, and rise is always taken as positive. Okay, so this correlates with the sign convention associated with KVL. Okay, now if you look around also, so you have to keep this thing in mind. Okay, first point. Now here your first step should be mark the polarity of the resistors as per the direction of current. So when I use this statement or sentence, I am saying that if suppose current is flowing like this, okay, so current is entering here, and here also you can see Ix is moving downwards like this. So here also current is coming here. Now we know that current always has a tendency to move from higher potential to lower potential. So higher potential to lower potential. Okay, so this is my first step about marking the polarity in the resistance part. Now I'll move in a clockwise direction from this part. So here I am going from negative to positive. So negative to positive is always rise. So rise is associated with a plus sign and value is given as 100. Now what about this? It is going from plus to minus. Again, this is also going from plus to minus. Plus to minus is always drop associated with a negative sign. So minus of drop is nothing but I into R. So what is my I? I is I1. What is my R? R is 10 ohms. Again, this is drop moving from plus to minus. So again, it will have a negative sign. What is that value of current here? That is nothing but Ix. So Ix multiplied by 5 ohms is equal to 0. So on looking into this problem, I have something like 5Ix plus 10I1 is equal to 100. Or you can say that Ix plus 2I1 is equals to 20. Is it clear, students? Students, is it clear? Please look into this
Yes,
loop
sir.
and try to understand each and everything that I have written here. Okay, so I'll take a screenshot of this. I'll share this with some of the students. They have asked for this. Okay, so just a moment. Okay, so this is our first part, like drawing this equation. So you please write this equation with you. Okay, so this is our first equation. Let's move to the second loop. Okay, so when we are moving to second loop, we have to first clear this. Okay, now, so this is my second loop. Okay, so this is, can you tell me name of this loop? So it was A, B. So this is B and this is
C.
C. So D, E, F and G. Am I correct, students?
Yes, sir.
Okay. Okay, so here applying KVL in loop B, C, F, G and again B. Your starting and your finishing point should be same. Okay, that's why we are talking about a closed circuit. Whenever we use the word loop, we are talking about a closed circuit, which is also known as mesh. Okay, now when I'm applying this again, I have a clockwise direction of, like, assumed direction of current here is clockwise. Please mark this. I'm marking this with a different color for you. Here the direction of current is given like this. Here it is upwards and here it is downwards. Okay, so this is your direction of current and my assumed direction of current is clockwise. Okay, so I'll move clockwise while writing the KVL equation. So so first point is, like, when we are talking about, the first step is always marking the polarity of resistor. Marking the polarity of resistor. So you can see here current is moving like this here. So it will always enter at the higher part and it will leave at negative part. Here its current is going upwards, means here I have plus and here I have minus. Here current is going downwards, so here I have plus and here I have minus. Is it fine, students? As per the direction of current, can you understand the polarity? How I have marked plus and minus here? Please respond yes or no. Again, I
Yes,
will.
sir.
Yes, sir.
What about others? Others, are you comfortable with this?
Yes, sir.
Okay, okay. So let's go in clockwise direction now. So when I'm moving, let me start with this. So I am here coming from minus to plus. That means rise in potential. So it is always associated with a plus sign. So rise in potential. So here we are talking about potential or voltage. So V is nothing but I into R. So what is that I and what is this R we have to write. So when I talk about I, so here I am going in clockwise direction, but the direction of current is coming in anti-clockwise direction. So here my current value I have to write as minus Ix, because if I am moving like this and current I am getting in downward direction, so I have to assume that direction in minus. Okay, so minus of Ix multiplied by 5. Students, is this clear?
Yes, sir.
Please mark this. Okay, now again, I'm going here from minus to plus. So this is rise in potential. Rise is potential is always associated with a plus sign. Value given is 50 here. Now here it is going from plus to minus. That means higher to lower, which is drop in potential. Drop in potential is always associated with a minus sign. What is my IR here then? I is given as I1 minus Ix multiplied by 2. Okay, again, when I come to this part, it is going from minus to plus. That means lower to higher potential or rise in potential. Rise in potential is always associated with a plus sign. What is value of my IR? I here is IY. But you have assumed direction in this way. Okay, clockwise. So it should come like downwards. But here it is showing IY is going upwards. So instead of IY, you will take minus IY here multiplied by 2 equal to 0. So again, we'll mark this. So where this star indicates the direction of current is opposite to the assumed direction of flow of current. Okay, that's why this minus Ix and minus Iy. Okay, so once we have this, okay, so I am having now minus 5 into Ix minus 2 Iy minus of 2 into I1 minus Ix plus 50 equal to 0. So minus 5ix minus 2iy minus 2i1 plus 2ix plus 50 is equal to 0. So 5 and 2, so minus 3ix, okay, minus 2iy minus 2i1 is equal to plus 50 is equal to 0. So what you can write instead of this? So your third equation is nothing but 3ix plus 2iy plus 2i1 is nothing but 50. Okay, so this is your second equation. Please look into this equation and try to understand each and every point. Each plus and each minus, why you have taken that assumption or why you have taken that value. Please look into it. If you are feeling anything suspicious, or if you are feeling any doubt in this part, please ask now. Is it fine, students? Getting the logic?
Sir,
Yes, sir.
stand for 2 ohm resistance.
Yeah, just a moment, just a moment. Okay, so this is, yeah, you are asking something. Please ask now. Tell me.
Sign for 2 ohm resistance.
Yes, yes. Can you say again? You need 2 minutes.
No, sir. Sign for 2 ohm resistance.
Sign for this one. So why we have this minus I, why you are saying? Be clear what you are saying. Speak
Yes, sir.
loudly, be clear. You want to know why this minus I, why?
Yes, sir.
Okay. So you can see here, so that this Iy and this Ix has the same reason why I have put a minus sign, because what we are doing, you can see that here we are moving in clockwise direction. So if I'm moving in clockwise direction, as per that clockwise direction, I have to assume. Okay. So when I'm moving in clockwise direction and when I'm looking into this 5 ohm and this 2 ohm resistor, so you can see here that the voltage across that particular resistor will be V is equal to I into R. But you can see here that you are taking direction in, like your assumption is, sorry, okay. So your assumption, okay, no, I will not use this. So your assumption is current is flowing in this direction. That means direction of current is this. Okay, this way current is flowing in my circuit. So you are going in this circuit like this as per your direction. But the direction of current given in the problem is opposite. That is, it is flowing in anti-clockwise. So we need to follow a sign convention so that we are taking care of all the current and all the values as per a particular direction, which we took here as clockwise direction. But here we found out that the direction is coming out to be opposite to that of our assumed direction. So that's why this minus Ix. Similar is the condition when current reaches, I mean, I'm talking about the assumed direction, that is clockwise. So it should come like this. But when I see here, I saw that Iy is flowing in opposite direction. So that's why again I have used this Iy with a minus sign. Is it clear, students? Who asked this doubt? What is your
Yes,
name?
sir.
Uh, name? Your name? Can you say
Santosh.
Santosh? Okay, Santosh Kumar. Okay. Santosh, is it clear now?
Yes, sir.
Okay. So let's go and talk about the third loop now. Okay. So for that, I have to clear this first. I have copied this. So let's go and see this. Okay. So now I have this third loop. Okay. So I'll be repeating the same part again. Okay. So it was A, B, C, D. Okay. So this is C, D, E, F. Is it fine, students? Loop name as per the names we have given, name that I gave. Is it
Yes,
clear?
sir.
Okay. Okay. So here again, applying KVL in loop C, D, E, F, and C, that is loop 3. Okay. So now, as per direction, first, my first point is always mark the polarity. Polarity of what? Polarity of resistors. Okay, so this current is going upwards. Okay, so it will always enter at a higher potential and it will leave at a negative potential. Okay, again this current is coming like this, so it will enter here as positive and leave here as negative. Okay, so this is my final part. Okay. So when I write this equation, I'll move from in clockwise direction. So I'm going from plus to minus, which is associated with always a negative sign as a drop in potential. Potential is current multiplied by the resistance. So it is 2 into Iy. Now you can see here that the assumed direction and direction of Iy is same. That's why I will directly write 2 into Iy here. This minus sign is associated with drop. Okay. And direction wise, it is all same. Now, this is going from minus to plus. So what it should be, students? Lower to higher potential. Lower to higher potential is known as what?
Positive.
Yeah, but it is known as what word you use for it?
Rise.
Rise. Okay. This is always a rise. Why? Because it is going from lower to higher. So rise is always associated with positive. Value given is 50. This is again a current. Okay. It is entering plus at positive and leaving out as minus. So this is drop in potential. So it will associate itself with minus sign. So IR drop is this total current, that is I1 minus IX plus IY, okay, multiplied by the resistance equal to 0. So this will be minus 2IY plus 50 minus I1 plus IX. Okay, so I'll use 3 here everywhere, and minus IY, 3IY equal to 0. Okay, so this all is nothing but 3IX, okay, minus 5IY minus 3I1 plus 50 equal to 0. Please look into this equation and see if there is any doubt. Okay, so let's save this somewhere. Okay, so now based on this, we have three equations. So I'll show you those all. Okay, so let me share this now. Okay, so we have this now. Okay, so one more thing. Okay, so this was our problem. Can you see the screen, students, where we have whatever we have done is there? Can you see this all three equations? Okay, so this was our problem, that we need to find out Ix and Iy. Okay, so when we are solving this problem, we divided this entire thing into three loops. Okay, namely 1, 2, and 3 here. So when we identified the three loops, we just mark the polarity as per the direction of current given in the problem. Okay, and also we applied the rise and drop in potential concept here to write the KVL equation. So this one is rise, both of them are drop. Okay, so it will have positive sign and other two will have negative sign. So first, it is not a big deal in the first loop. Okay, because everything is as per the assumed direction, and the direction of current given in the circuit is also same. So we don't have to take care of any of the values of Ix here in other term. Okay, when we look into the second loop, okay, here the direction, assumed direction, is current as clockwise here. Okay, and you can see here that current is flowing in this particular fashion. So I'll write KVL equation for this. So if I move in clockwise direction, I can, as per the direction of current Ix, Iy, and I1 minus Ix, I'll mark the polarity. So wherever the current will enter, it will be marked as positive. Okay, and wherever the current will leave the resistor, it will be marked as negative. So based on that, I mark this. Okay, So now when I move in clockwise direction, if I'm going from negative to positive, it is always rise. So that's why plus sign here. But when I calculate the drop, or when I calculate the voltage, which is nothing but current into resistance, so my direction, assumed direction of current is clockwise, but here it is showing that the current is flowing in anti-clockwise direction. So I have to take a minus sign here. So it is minus Ix into 5. Now from minus to plus, it is always rise. So it is 50. Again, plus to minus is associated with a drop. So it is I1 minus Ix current multiplied by 2. Again, when I came here, it is from minus to plus, okay, as per the clockwise direction. So, but it is, so from minus to plus, it is a rise in potential. So I have a plus sign, but I found out that the direction of current given in the circuit is opposite to that what we have considered. So the direction is here as per this is anti-clockwise, and we have assumed a clockwise direction. So that's why this minus Iy sign. Here we have mentioned that the direction of current is opposite to the direction of the assumed direction of flow of current. Okay. So when we write this and solve, we get an equation like this: 3ix plus 2iy plus 2i1 is equals to 50. Okay. Now the last part where we have this particular loop. So we'll again move in clockwise direction. Based on the direction of current, we'll mark the polarity as plus minus. Okay. Here also plus minus. So when I move here, it is 2 into Iy with a minus sign because of the drop, plus 50 because of rise in potential, because we are moving from lower to higher potential, and again a voltage drop since the current is entering here and leaving out here. So I1 minus Ix plus Iy multiplied by 3. So minus is drop 1. So when I solve this, I get something in terms of 3Ix minus 5Iy minus 3I1 plus 50 equal to 0. Is it fine, students? Okay, now you have three equations like this. Okay, so please note that in this particular part, please note that here the now if you look here, it is I1 Ix, first equation. Here it is Ix, I1, Iy. Here it is Iy, I1, Ix. So I1, Iy, Ix. Okay, so you can see that here all my three unknown quantities are there. Here also all three unknown quantities are there, but here only two. Iy is missing because Iy doesn't don't have any relationship with my first loop. Okay, if you want to see, I can show you this. So you can see here in question itself. Okay, so you can see here if we are talking about this loop, so this Iy has nothing to do with this particular loop. So we won't have any Iy in this particular KVL equation. So why I'm saying this? So we are associated with these quantities. So that means we need three equations and three unknowns. Although in the first equation I don't have the one unknown, I only have two unknowns. So what I'll take, instead of Iy value, I'll take 0 coefficient for Iy. Okay. Can I write that this as 0 into Iy? So this is 0 only. But I am taking the components in terms of Ix, Iy and I1. Okay. GV Satya, you write, can we write like OIY? What is this? 0 Iy. Yes, yes, yes. This one. Okay. So this means 0 only. So why we are doing this? So if you look carefully, this is something like 5, 7, 3, 0, 2, minus 5, 10, minus 2, minus 3. So this is a matrix. Matrix whose components, whose coefficients are this, with the variable as Ix, Iy and I1. What this is equal to? This is equal to the constant values. That is 100 minus 50 minus 50. Okay, so what you did, you solved these, like you wrote the KVL equation and get equation in terms of Ix, Iy and I1. Okay, so you got this in terms of these three unknown quantities, and now you are taking out this in terms of a matrix. Okay, now if you have the scientific calculator and if you'll put these values, you can get directly the value of Ix, Iy and I1. Okay, but one more thing you can do is like your this determinant or this matrix is nothing but delta. Okay, so that delta you can write it as 5, 0, 10, 7, 2 minus 2, 3 minus 5 minus 3. So this is your delta. Okay, now we have delta 1 also, delta 2 also, and delta 3 also. Okay, so if this is delta, my delta 1 is nothing but you'll replace the first row with this right hand side. Okay, with this constant value. So first row is replaced, so it will be 100 minus 50 minus 50, 0, 2 minus 5, and 10 minus 2 minus 6. So this is your delta 1 where you're replacing your first column with this particular part. I'm sorry I used the word row. You have to replace the first column with this constant. Now similarly the same concept applies to del 2. Now you will be replacing this second column with this constant value. So this will be 573, 100 minus 50 minus 50, and this is as 10 minus 2 minus 3 as it is. Okay, okay, so okay, so this is our del 2. Similarly, what I should do for del 3 students? Students, tell me what I should do for del 3.
The last column should be replaced by this 100.
Okay, very good. Okay, so now your last column is being replaced. So this is 5, 7, 3, 0, 2 minus 5, and last column is now 100 minus 50 minus 50. Okay, so now you have del 1, del 2, and del 3 in terms of a matrix. So your value of Ix is nothing but del 1 by del. Your value of Iy is nothing but del 2 by del. And your I1 is nothing but del 3 by del. Okay, so this is matrix. Okay, del 1, del 2, del 3. So suppose, okay, so I'll just give you, because you know this. So suppose I'll give you this as a matrix as A, B, C, D, E, F, G, H, I. Okay, so if I want to calculate the module or the value of this matrix, okay, so I'm talking about that thing. So this is nothing but A multiplied by, when you're talking about A, replace this row and this column. Okay, so you do like this. So I'm talking about A, so you just delete this. So this will be E into this minus F into H. So it is E into I, sorry, this will be E into I minus F into H. Okay, now you'll go for the second part. Okay, oh, sorry. So A, B, C, D, E, F, G, H, I. So now when I'm going for the next part, so this is now having a minus sign, that is B multiplied. So I'm talking about B. So what I'll do when you're talking about this thing, so you just remove this and this. So what is left? D into I minus G into H. D into I minus G into H. Okay. Now similarly, if I go for the third part, so it will be plus C. Okay. C. So I'm looking into this. So I'll now remove this. So it will be D into H minus G into E. Okay. So this will give me the value of that determinant. So when I'm writing as Ix equals to del 1 upon del, so I'm talking about this value. You have to calculate this value and then you have to get this value of delta, and for del 1 and del 2 and del 3 also you have the matrix. Okay, so for example, sorry. Okay, so for example, this is our case. So I'll just show you this part. Okay, so when I'm talking about this 5, 0, 10, 7 to minus 2, and 3, minus 5, and minus 3. Okay, so this is my, I want to calculate the magnitude. Okay, so here it is 0. So this is 5 multiplied by 2 into 3 minus 6 minus 5 into 2 10 and with a minus sign. So this is 0, so everything will be 0 here in this case, but for you to understand I'll write plus 0 into, so when I'm talking about 0 it is 7 into minus 3 minus 21 minus 3 into minus 2. So minus 3 into minus 2 is minus 6. So although it is all 0, but I told you how it will come. Okay, now finally plus 10 multiplied by 7 into 5 minus 35 minus 3 into 2, that is minus 6. Okay, so here I got 16 fives are minus 80. This is 0 and here it is 410. So this is 490. So you are getting the value of determinant as 490. So similarly, you have to calculate for del 1 and del 2 and del 3. To find I1, Ix as del 1 by del, Iy as del 2 by del, and Iz by I del, I3 by del. Did you got this, students? Are you getting the logic? Okay, so I'll show you the solution part now. Okay, so for that I have clear
So,
this.
so you
Yeah.
made an error in the
Okay.
determinant. It should be minus 390.
Okay, it is coming minus 390. We'll just cross verify. Okay, maybe in hurry I did that. Okay, so now okay, so that equation I don't need. Okay, this is just equal. So your matrix is now in this form. Okay, Ix I by I1, this plus this. So del is, you can see this part as minus 498 is coming. Akash, Akash said or somebody else said. Okay,
Okay, sir.
okay, no problem. Okay, no problem. So this is minus 498 is coming. Okay, and similarly they have calculated del 1 by replacing the first row with this 100, 50 minus 50 minus 50. Del 2 by replacing the second row with the constant values. Okay, and similarly you can do for the third one also. Okay, so I mean to say when I'm talking about this, del 3 is nothing but my determinant under is 573 0 to minus 5 and finally 100 minus 50 minus 50. Okay, so can you tell me this value? Anyone? Please, I need 4 and 5 people to tell me this value, to like confirm this value. So it is 5 multiplied by minus 100 minus of 50 into minus of, just a moment, minus minus plus minus of 250. Okay, plus 100.
What does that
So
look like in your life?
minus 35 minus 6. Just a moment. 100 minus 35 minus 6. So this is 355 the 70, 71, 40. You're saying something? Say it clearly. Okay, so this is my 1750 and this is
So
41.
minus 2160.
Okay, so this is 1750. What you got? Answer? Students, please tell me what is the answer of this.
I got minus 2160, sir.
Okay, just a moment. Okay. Okay, let's see. So how we did 5 into this is minus 100. Minus of this 2 is positive 250 with a minus sign. So 350 into 5. 0, 5 to the 17, 1750. Now this part is 0, so I'll use this as 100. So 100 multiplied by 7 into minus 5 is minus 35. 3 into 2 is 6 with a minus sign. So this is 41. So this is 4100 and this is 4100 with a minus sign. And this is also with a minus sign. How you're getting what value you're getting, all of you? Okay, you confirm this del 1, del 2 and del 3 value now. All of you, I want this answer now. Anyone?
So I got 550.
Your voice is breaking.
So minus 5850, sir.
5850. Yes.
Minus 5850.
Okay. Okay, so it is minus 5850. Okay, so when you have this formula, you can now calculate del 1 as Ix as del 1 by del. So your del 1 is 1900. Del is minus 1490. So this one is your Ix. Iy is minus 250 by minus 490. So this one is your Iy. Can you tell me about I1 now? Is del 3 upon del. Del 3 you have calculated as minus 5850 upon minus 490. So can you divide this and tell me? Okay.
Sir, it's 11.93.
11.93. I marked 12, no problem. So I1 is 11.9. Okay, so here you can see you're associate you're getting Ix in terms of minus 3.87. Okay, so the negative sign on Ix implies that the actual current flows in the direction opposite to that given in the figure. Okay, so if I'm getting minus Ix value as minus 3.87, that means if this is my circuit diagram, okay, so you can see that Ix is going downwards. Okay, so this value I am getting as it is going downwards as minus 3.8 something. Okay, so what does this mean? That means if this is minus 3.8, so instead of this, if I'll replace this and sorry, and if I am writing like this, so then I can write Ix as plus 3.8. So here I mean to say that if this is like, if I'm talking about the reference in terms of magnitude to be same, if this is 5 amperes, this is minus 5 amperes. Okay, so if you're getting some answer I1 is equal to minus 5 amperes, so don't think like I have got a wrong answer. It only means that whatever assumption is there as per the circuit diagram, whatever answer you're getting, if you're getting answer in negative, that means your assumed direction is opposite to that of the actual problem. Okay, so this is one thing you have to keep in mind. Any problem, students, in this question? Please ask, you're free to ask now. Okay, so this is actually a complex problem where we have to calculate as per the matrix and the other things. Okay, so somebody responded in chat. Okay, Satya Akshat. Okay, good. So this is one thing. Okay, now